A muffler is a device used to lessen the extremely loud noise that is generated by the gas that travels through the exhaust valves in a combustion engine. The muffler plays a small but an important part in the exhaust system of a machine, acting as an acoustic soundproofing device. The three main functions of the muffler are to remove hot or poisonous gases away from the motor, to reduce exhaust emissions, and to reduce the noise generated from the internal combustion engine. This is achieved by passing the sound pressure through a series of resonating chambers that have been harmonically tuned to oppose the sound waves and hence cancel them out. In order to fulfill its function, the muffler must possess certain properties. As the primary function of the muffler is to reduce noise, it is therefore shaped in a certain way to effectively minimize sound, which is achieved through chambers and area discontinuities. In order for the muffler to withstand high temperatures, back pressures, and the corrosive nature of the exhaust gases, the muffler must be manufactured from a highly durable material, such as stainless steel. Size is also an important consideration for the muffler, as being too small will cause it to be ineffective at performing its function, but being too large will make it too heavy and create support issues. This photo is a good indication of an appropriate size of a muffler on a lawnmower. The muffler is believed to be produced through sheet forming methods due to its seamless nature of the thin walls and appearance of the holes. This suggests that it was created by forming together three thin metal sheets. These sheets were plastically deformed by tensile stresses in the process of deep drawing. As a result, two sheets were drawn into a cylindrical shape with a closed-off bottom, and when connected, created the muffler shell. The remaining sheet is mildly deformed in the center by a rounded punch to create a barrier for noise reduction. The smooth appearance of the holes on one side and the rugged appearance on the other reveal that the holes were created through unidirectional piercing. This also contributes to the safety of the part, as no sharp edges are exposed. The first step of the entire metal working process would be to have the workpiece deep drawn into a shaped die to create its cylindrical shape and the indentations on its surface. The middle sheet is pressed with a rounded punch to create a barrier for noise reduction. The next step would be to pierce the holes and have the scraps removed from the workpiece. The three sheets are hemmed together and sections around the perimeter are pinched to ensure that the sheets do not rotate against each other. Although this is a fairly basic joining method, it is the cheapest method to get the job done. The final step would be to have the top piece welded on. Whilst from the image it is not immediately obvious that this part was welded on, we can clearly see the weld spots when the piece is cut in half. The benefits of welding over other methods of joining would be its efficiency and low cost.